Okay, here is the traditional substitution on the what to know day 28 ditto. And you'll notice this first one here, the first two equations are both equal to y, so we're very familiar with setting the equations equal to one another. In a sense, we're going to take this 3x minus 1 and replace it with this y here. This bottom equation is a line, and the top equation is a parabola, so keeping in mind trying to find the places that a line and a parabola intersect, we have options. They could intersect twice, they could intersect once, and they could intersect 0 times. So those are all possible outcomes for this problem. So putting the 3x minus 1 in for that y, or in other words, setting the equations equal to one another is what it looks like we're doing. We end up with a very traditional quadratic, which we should set equal to 0 to use the zero product property. So I'm going to keep the x squared on the right side, bring this 3x over, and bring this 1 over so that I could begin to factor. If it doesn't factor, I'll use the quadratic formula, but hopefully these all factor, and we can stay away from our calculator. So there's our factoring, and we get the answers of 6 and -1, which we should plug back in when we're solving the system to find y. And I'll go ahead and write my answers as coordinate points to represent the coordinate points of where these guys intersect. So these x values go first. If I plug 6 into this bottom equation here, that's the easiest place to plug it into. I get 17, and if I plug -1 into that same equation, I get -4. Now what I should do is take these x values and plug them into the top equation to make sure I get the same answer. That way I know it's correct. But for time, I'm going to skip that. So there's the two places that parabola and that line intersect. All right, now they gradually get harder. There's different types here under these traditional substitutions. Because on this one, we have one of the equations that's equal to y, and we're very used to taking this part and plugging it in for y. But putting an x squared here and then later squaring it would generate an x to the fourth term. So I'm going to stay away from that, okay? And the part I hope you recognize is that this x squared does match this x squared, and I can do a different type of substitution if I could get this x squared by itself. So I'm going to take this 4 and move it over to this side by adding 4. And in doing so, I create an equation that's equal to x squared, which means I can substitute this part for this x squared since it's equal to x squared. So I'm going to rewrite the top equation, and I'm going to put y plus 4 in for the x squared instead. Y plus 4. Okay, so I put that here. At this point, to save some space, this y minus 1 squared has to be multiplied out. So I'm going to multiply it out and write that here just to save some space. If you need to use a generic rectangle, use a generic rectangle, but you should get that polynomial with the 25 still over here. Okay, so we substitute a little unconventionally. Now I'm going to use the zero product property, so I'm going to get everything on one side of the equation and get it ready to be factored. The y squared is going to go first. I accidentally wrote x there. Let me change that to a y really fast. Sorry about that, gang. Habit. And now I'm going to combine these y's. There's a -y when you combine those, and then there's this 5. But I'm going to bring the 25 over in the same step, so subtract 25 from that 5 gives me -20. All right, so I brought everything over to the left side and put it in the proper order, ready to be factored. And then when we factor this, looks like a y minus 5 and a y plus 4. I get two answers of y equals 5 and y equals -4. So if we go back up here and take a look at our original equations, we have a circle and we have a parabola. And a circle and a parabola could intersect in 4 places, 3 places, 2 places, 1 place, and no places. So we're going to take our y values and see how many answers we actually get. If I take this 5 and plug it back in for y, where's the easiest place to plug it into? It's probably this second equation here. So let's head off to the side here and put 5 in for the y. And we get this equation here, which we can solve for x, moving the 4 and then square rooting. And because that's x squared, our answer is going to generate a plus or minus The square root of 9 is conveniently 3. So this plus or minus is because we had that x squared, which means y is 5 when x is 3, y is 5 when x is negative 3. So those are two separate answers, two separate locations. Okay, x is 3 and negative 3 when y is 5. Then we take our other y value and we plug it in for the y value into that same bottom equation. And we start to solve that one, adding 4 to both sides, we get 0. And we don't get plus or minus 0 because the square root of 0 is 0. We don't need to write plus or minus, so we get 0. So that's a third answer that this guy generates. So this parabola and this circle intersect in 3 places. All right, I think we got time for one more, so let's head down to the second one. Let's do A. I see I have y equals x minus 1 here, and then I have a circle here, so a line and a circle, and it looks like we're going to take this x minus 1, which is equal to y, and put it right in there for that y. So I'll go ahead and write this out so you can see it. There's that x squared, and then we got an x minus 1 squared is equal to 13. So make sure whatever you substitute, you use parentheses. The squared's on the outside. We've got to multiply that out. If you need to use generic rectangles, use them. So all I did in that step was multiply the x minus 1 times itself. And now we're going to get this thing ready to be factored. So I'm going to combine like terms, and I'm going to bring the 13 over. And now we'll factor. It looks like we should extract out a 2 here, common term, before we factor this to an x minus 3 and an x plus 2. So the answers I get so far are 3 and negative 2. And the easiest place to plug those back into is that top equation. So 3 is one of my x values. Plugging that in, looks like I get 2 for the y value, and negative 2 looks like I'm going to get negative 3. So there's the 2 points of intersection. All right, I'm going to let you try to do the last one. I'll give you a hint, though. Substituting in a y, it looks like it's going to be ugly because this is a squared, and when you put a squared here into a squared, you're going to end up with an x to the 4th term. So let's avoid that. Let's take this 4, bring it over to this side. I'll stick it at the end of that equation, and you're going to put 2y minus 4, which is equal to x squared, and you're going to put it right there for x squared. So rewrite this top equation, putting 2y minus 4 in this spot right here. And then it turns out to be very similar to the one up above. Okay? All right, so that's some traditional substitution. If you want to watch the next video, I'll do that ugly substitution next.